There is a pipeline system being built across Saudi Arabia that most of the world knows nothing about. It stretches hundreds of kilometers inland from the coast, carrying something more valuable than oil. Billions of liters of seawater are being pumped through massive concrete and steel arteries deep into one of the driest places on Earth.
This is not a backup plan. This is not an experiment.
This is survival infrastructure on a scale never seen before, and it is happening right now. Saudi Arabia consumes more water per person than almost any nation on the planet. The average Saudi uses over 300 liters of water every single day. For context, the global average is less than 200. But here is the problem. Saudi Arabia has no rivers, no lakes, barely any rain. The entire country sits on top of a desert that has been dry for thousands of years. So where does all that water come from? For decades, the answer was underground. Massive aquifers buried beneath the sand, filled with ancient water from a time when this region was green. The Saudis have been draining those reserves faster than they can ever be replaced. Some estimates suggest that within the next 2 decades, those aquifers will run completely dry. That is when the kingdom made a decision that would reshape its entire future. If there is no fresh water left underground, then they would take it from the sea. Not in small amounts, not as a temporary measure, but as the primary source of water for tens of millions of people. The plan was audacious. Build the largest desalination infrastructure on Earth. Construct pipelines that could move entire rivers worth of water across a country the size of Western Europe. Engineer a system so advanced that it could turn the Red Sea and the Arabian Gulf into the lifeblood of a desert nation, and they had to do it before the water ran out. Most people think of desalination as a coastal process, a few plants near the ocean producing water for nearby cities. But Saudi Arabia needed something far more complex. They needed to send that water inland, to Riyadh, a city of over 7 million people sitting more than 400 kilometers from the nearest coast, to industrial zones in the interior, to new megacities being built in the middle of nowhere. The only way to do that was through pipelines, not ordinary pipelines. These are some of the largest water transmission systems ever constructed. Some of them measure over 3 meters in diameter, concrete-lined steel giants capable of moving thousands of liters per second. They run underground, across highways, through mountain ranges, across terrains so harsh that construction crews had to work in temperatures exceeding 50 degrees Celsius. The engineering behind this is staggering. Water does not flow uphill on its own. Riyadh sits at an elevation of over 600 meters above sea level. That means every drop of seawater has to be pumped upward across hundreds of kilometers of desert. The energy required is immense. Massive pumping stations dot the route, each one consuming enough electricity to power a small city. These stations operate around the clock, maintaining pressure, controlling flow, ensuring that water reaches its destination without loss or contamination. The entire system is monitored in real time by centralized control rooms that track every valve, every sensor, every fluctuation in the network. A single failure could cut off water to millions. But before the water even enters those pipelines, it has to be transformed. Seawater cannot be used as it is. It is full of salt, minerals, bacteria, and particulates. Desalination plants along the coast take in ocean water and force it through reverse osmosis membranes at extreme pressure. These membranes filter out salt molecules, leaving behind fresh water. The process is energy-intensive and expensive. Saudi Arabia operates more than 30 major desalination plants, producing over 5 million cubic meters of fresh water every single day. That is more than any other country in the world. The plants run continuously, fed by the ocean on one side and connected to the vast pipeline network on the other. The scale becomes even more surreal when you consider the speed at which this system was expanded. In the 1980s, Desalination provided less than 10% of the country's water. Today, it accounts for more than half. And that percentage is growing. New plants are under construction. Existing facilities are being upgraded with cutting-edge technology to increase output and reduce energy consumption. The kingdom is betting its entire future on the ability to turn seawater into a sustainable resource. But sustainability is a complicated word when you are talking about a process that requires this much power. Desalination is one of the most energy-hungry industrial processes in existence. For every liter of fresh water produced, a significant amount of electricity is consumed. In Saudi Arabia, most of that electricity still comes from burning oil and natural gas. The irony is impossible to ignore. A country built on fossil fuel wealth is now using those same fossil fuels to create the water it needs to survive. This creates a feedback loop. More water demand means more desalination. More desalination means more energy consumption. More energy consumption means more carbon emissions. And more carbon emissions contribute to the very climate change that is making the region even hotter and drier. The environmental cost does not stop at energy. Desalination plants produce a byproduct called brine. This is the concentrated salt and chemical residue left over after freshwater is extracted. For every liter of freshwater, about 1.5 liters of brine is created. That brine is typically pumped back into the ocean. In small amounts, the ocean can dilute it. But Saudi Arabia is not producing small amounts. Billions of liters of brine are being discharged into the Red Sea and the Arabian Gulf every year. The brine is hotter and saltier than the surrounding seawater. It sinks to the ocean floor, creating dead zones where marine life cannot survive. Coral reefs, fish populations, and entire coastal ecosystems are being affected. Scientists have raised alarms, but the infrastructure keeps expanding. There is no easy alternative. Then there is the human side of this story. The people who depend on this system have no idea how fragile it really is. If the desalination plants were to shut down for even a few days, major cities would face catastrophic water shortages. Hospitals, schools, homes, and businesses would lose access to clean water. The government has built strategic reserves, underground storage facilities that hold enough water to last a few weeks. But those reserves are a buffer, not a solution. The real vulnerability lies in the dependency itself. Saudi Arabia has engineered its way into a corner. It cannot go back to relying on aquifers that no longer exist. It cannot import enough water to meet demand. It has no choice but to keep the desalination machine running at full capacity, no matter the cost. This is not just a Saudi problem. It is a glimpse into the future of water on a warming planet. More than 2 billion people live in water-stressed regions. That number is expected to grow. Desalination is being adopted by countries across the Middle East, North Africa, and even parts of the United States and Australia. The technology is improving. Solar-powered desalination is being tested. New membrane materials are being developed to reduce energy consumption. But the fundamental challenge remains. Turning seawater into fresh water at scale requires enormous resources. And in a world already facing energy and climate crises, that trade-off is becoming harder to justify. Yet Saudi Arabia is doubling down. The kingdom is not just maintaining its current infrastructure, it is expanding. New megaprojects like Neom, a futuristic city being built in the northwest, will require even more water. The developers have promised that Neom will be powered entirely by renewable energy and that its water will come from sustainable desalination. But the timeline is aggressive, and the technology is still unproven at this scale. If Neom succeeds, it could become a model for how desert nations can build water-secure cities in the age of climate change. If it fails, it will be a monument to overreach. There is also a geopolitical dimension that cannot be ignored. Water is power. Control over water resources has shaped conflicts and alliances for centuries. Saudi Arabia's investment in desalination gives it a degree of independence that many of its neighbors do not have. Countries like Jordan, Yemen, and Iraq face severe water shortages and have limited ability to desalinate at scale. In a region where water scarcity is becoming a national security issue, Saudi Arabia's infrastructure could be leveraged for influence. Water diplomacy is already a reality. Shared rivers and aquifers are sources of tension. Desalination shifts the equation. It allows a nation to create its own water, but only if it has the wealth and energy to sustain it. Still, there is an uncomfortable truth beneath all of this innovation. No amount of engineering can change the fact that Saudi Arabia is living beyond its natural means. The lifestyle, the consumption, the massive urban projects, all of it depends on a system that is artificially sustained. The desert is not meant to support cities of millions. It is not meant to have golf courses, fountains, and endless green parks. These things exist because the kingdom has the money and the will to force them into existence. But money cannot create water out of nothing. It can only move it, filter it, and distribute it. And every step of that process has a cost. What happens when the costs become too high? When energy prices spike? When climate change accelerates desertification even further? When the ocean itself becomes too polluted or too warm to be a reliable source? These are not hypothetical questions. They are scenarios that planners are already considering. The Saudi government has acknowledged that water security is one of the top strategic risks facing the nation. They have launched initiatives to reduce consumption, promote water recycling, and educate the public about conservation. But changing behavior in a culture accustomed to abundance is difficult. The infrastructure may be world-class, but the mindset has not caught up. And then there is the question of what this all means for the rest of us. Saudi Arabia is an extreme case, but it is not unique. Cities around the world are grappling with water scarcity. Cape Town nearly ran out of water in 2018. Mexico City is sinking because of over-extraction from underground aquifers. Parts of California rely on desalination to supplement dwindling supplies. The difference is scale and speed. What Saudi Arabia is doing is a preview of what might become necessary in dozens of other places. If desalination is the future, then we need to confront its limitations honestly. We need to find ways to make it cleaner, cheaper, and less damaging to the environment. We need to ask whether building cities in deserts is wise, or whether we should be rethinking where and how we live. The pipelines that carry billions of liters of seawater into the Saudi desert are more than infrastructure. They are a statement, a declaration that humanity can engineer its way out of natural limits. But they are also a warning, because every liter of water that flows through those pipes is a reminder of how fragile our relationship with the planet has become. The question is not whether we can build these systems. We already have. The question is whether we can sustain them, and whether, in the long run, they will save us or trap us in a cycle of dependency we cannot escape. Saudi Arabia is betting everything on the answer being yes. The rest of the world is watching to see if they are right.